Hey robot makers, hope you're having a good day so far. So do you want to design 3D printable models using free software? Do you want to know how to use FreeCAD? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, I've only got a couple of slides and then we're going to get straight into the demo today about how to use FreeCAD. So what makes FreeCAD different than other CAD software? So the first thing is it's completely free, open source, and actually very easy to learn. You can make 3D models that you can print out on your 3D printer. I've got the Prusa Core 1 behind me there. That's where I do all my printing now. And you can design parts using something called parametric modeling. We'll get into that in the demo very shortly. And of course it runs on Windows, Mac OS, Linux, including the Raspberry Pi. So if you've got a Raspberry Pi, you can run this software very easily. Just do sudo apt install FreeCAD and you'll be up and running in no time. And one of the really cool things as well is it works completely offline. There is no requirement for an internet connection. There's no checking if you've got a license or limits how many documents you can have open. Fully functional and featured software. And it has a really vibrant support community as well. So head over to freecad.org to download that today if you want to get that on your Mac, Windows, Linux machine. Or like I said, you can install that using the sudo apt get install method as well. So today what we're going to be looking at is how to design this little chassis for one of our robots. This is the SMARS robot, which is a little tracked object detection, object following robot built around the Arduino. So this one is the Arduino Uno Q, which is the latest processor single board computer from Arduino. And this chassis is what we'll be actually building today. It's got lots of different things that we can learn. So we'll be learning all kinds of aspects of that. We'll learn how to navigate around FreeCAD confidently, how to do parametric sketches so we can design shapes that can be easily modified. We'll use some professional CAD techniques using constraints, construction geometry and references, and we're going to apply some design for manufacture principles, making parts that print really well. And we'll also be able to export this at the end to generate an STL file for our 3D printer. So if you want to follow along with this, I've spent all weekend building a course for this completely for free. FreeCAD. So go to kesrobots.com/learn/FreeCAD_SMARS/ and you'll be up and running. I'll show you that as well in a second. And if you like these kind of videos and you want me to make more of these, definitely give this video a like, drop a comment below, let me know what software you currently use. I'm a big fan of Fusion 360, but I also wanted to try out FreeCAD just to see where that's up to. It's had quite a lot of development in the past couple of months. And if you've not subscribed to the channel, please give me an early Christmas present by subscribing to the channel, and I'll really appreciate it as the channel grows and is seen to be growing successfully. I do go live as well every single Sunday at 7 o'clock GMT, so you can hang out with me and chat as well. Okay, let's get into building the SMARS chassis with FreeCAD. So what I'm going to do, I'm just going to get my FreeCAD on screen there, and here we go. So I've downloaded FreeCAD. I'm on FreeCAD 1.0.2, which is the latest version as of this recording, and I'm going to straight away just go for an empty file. So the first thing I want to do is just get my notes open to the side, and what I'm going to do there is just go to kesrobots.com/learn/ I'm going to get it open on my second screen. And then FreeCAD /SMARS_SMARS. There we go. Okay, so what I'm going to show you as well is if we just go over to here, if you just go to the free courses, click on the Learn FreeCAD, it'll take you to this page here. And the thing that's taken me so long this weekend to do, as well as putting like this text together, is capturing all the screenshots shot by shot of exactly how to create this base. So I've had to go step by step, not missing a single step on how to create this. So this is what I'm going to be showing you today. So the first thing I wanted to showcase was how to navigate around FreeCAD. I'm going to keep saying Fusion 360, FreeCAD. So I've got this set to, let's go over to the software itself. You can see down here where it says touchpad. If you click on that, there's lots of different settings that you can choose from if you're familiar with a different package. I don't mind the touchpad. I find this is fine to work on. So what I'm going to do, the first thing I'm going to do is save this. I'm going to go to File, Save As, and I'm going to save this in my Downloads folder. Oh, actually, we'll save it in the Smiles folder. Let's just call this Live Demo. And I can actually close down that other little model that was just in the model tree. So this on the left hand side, this is called a model tree. This is where all the operations that we do kind of stack up. And you can see there's also that little start welcome screen as well. So I'm just going to close that out. And we'll make a start. So the first thing we want to do is create the base of our robot. So these Smars robots are essentially a rectangle that we then cut out a shape from. So the first thing we want to do is we want to create a new sketch, and we want to create this on this XY plane that you can see here. So this plane here, this one has been selected as yellow. That's where we want to create it. And we get this usual kind of XY two-dimensional plane view. So on the left hand side you can see that this thing's where it says model and task. You can flick between the model tree and the tasks, which is the kind of current operation that you're doing, and any operations, anything that's in there will appear over there. So what I'm going to do first of all is I'm going to use the rectangle tool. So I'm going to create a rectangle. I'm just going to create it like so. You can type in the dimensions as you go, but I just wanted to show you the kind of different tools that we'll use. So currently we've got this rectangle. These little red things mean that these are parallel lines, so it's parallel left and right, top and bottom rectangle. So if I now press the dimension button, which is this little sort of sideways A, I can now click on a line there and I can type in 70, which is the first dimension. If I click on the left hand side, then 58 is the other dimension. Now currently this isn't locked into the origin point. We could lock that little bottom corner there to the origin point, but I actually want the origin to be completely central so that the origin is kind of going straight through the bottom of our design there. Now on Fusion 360 they have this nice kind of diagonal line with a point in the middle. That's what we're going to recreate to do exactly that. So if I click on this line tool here, looks like a little lollipop, or the shortcut there is G and L, and if I hover my mouse in the corner, you'll see that we get this little double arrow. It looks like the symmetric constraint. That means that we're actually connected to that point there, and similarly when I go down here, we'll also get that symmetric constraint telling me that it's going to lock to that point that it's near. So I'm just going to do the same there and there. And then I'm going to click on the point tool, which is this one here, G and Y for the shortcut for that. And then if I just click on this line here first of all, I can then use the constraint, coincident constraint, to lock that, as well as it being on that axis, to this line here. So it's now sort of centered right in the middle of the rectangle. Now, when we create geometry in FreeCAD, the end geometry that we want to work with is usually a enclosed shape, an enclosed polygon of some kind. Now this sort of shape here, this X, we want that to be construction geometry. We don't really want that to show up in the final result. So what I'm going to do is I'm going to click on this, and then I'm going to click on this little toggle geometry button here. So shortcut for that's G and N, and you'll see there it goes to like a blue color. Click that again, and now what I can do is I can click that little point right in the very middle, so it's gone green, if you can see that. And if I also hold down, I'm holding down Command on the Mac with the center point there, it's now locked those two together. The whole thing's turned green, which means it's fully constrained, and that means that it's locked. There's no kind of variance. The shape is locked because it's connected to the origin point, and all the other points are connected together as well. So that's the first thing that we've completed. Let's close that, and you can now see we're in the if I hold down the Option key on the Mac, I can kind of rotate around my view there. That little dot that appears is kind of the pivot point, so depending where you hold it, it'll pivot around that point. Now I found FreeCAD to be quite confusing to begin with on navigating around the screen. So as I zoomed in, if I zoom in at a corner, it kind of zooms in relative to that corner, if you can see that. And very quickly you think, well, how do I move? How do I get back to there? If you hold down Shift and just move so I'm just moving my mouse up and down by holding down Shift, you can sort of recenter very easily what you're working on. And there's also some buttons up here. That very top left one with the magnifying glass will kind of just recenter you in your view. You've also got the number keys, so this will become a lot more clearer when we start making this shape have some structure. So what I'm going to do next, I'm just going to scroll down so I've got to the part where I'm building out the next piece, which is just here. So I'm going to pad the sketch now. I'm going to add some actual height to this. So currently this is just an outline of a rectangle. So if I make sure I've got that sketch selected on the left hand side, and I then click this pad button here, it's like a little floating rectangle. If I click on pad, it's going to give me a default height of 10. We want that to be 32 to be a Smars robot. If I press tab, it'll update that view there, and we can actually go ahead and close that out by clicking OK. Now if I now rotate around this by holding down that option key, you can see there we've got different views. Now if I get really confused and my view's all messed up like that, I can use the number keys. If I press 1, it's going to rotate to the side view. Number 2 will be top down. Number 3 is the left hand view. Number 4 the right hand view. 5 is the bottom, I think, and then 6. So you can actually go to the view menu and see all these shortcut keys. So standard views, there we go. So 1 is the front, 2 is the top, 3 is the right, 4 is the rear, 5 is the bottom, 6 is left. And you can even store the current working view. So I find if you press 0, you get back to that nice kind of default view there. And again, we can also click on that F and V to fit all. So if I do VF, was it? If I do VF, it'll then take us to this shape here. So that's the beginning, that's the kind of main body of our Smars robot. We need to now cut out different parts of this so that we can bring this robot to life. Okay, let me just go to the next page. So we need to create a shell and we need to fillet the edges. So the first thing we want to do is we want to create what they call a pocket. So let me just find where I'm up to on here. Well, there's two ways of doing this. We can either create a pocket, which is we define some geometry and then kind of knock out that from the shape, or we can use the thickness tool, which is this little one just here. So if I select that top edge, that top face, and I use the thickness tool, I can define how thick I want this to be. So I actually want this to be 3 millimeters. So I'm going to click over here where it says thickness and say 3. So that's looks quite chunky. Now, one of the unusual things about the Smars robot is that the outside walls are 3 millimeters, but these kind of top and bottom edges are actually 2 millimeters. So we'll have to do some extra maneuvering of that in a second. But the first thing we want to do is just apply that thickness. So we've done that. Then what I want to do is I want to round all the edges. Smars has got these really nice rounded edges. So all the bottom edges and all the side edges are also nice and round. So what I'm going to do next, I'm going to click OK on there to finish that one. I'm now going to use the fillet command, which is this one here with the little rounded edges. So if I click on an edge, I hold down command, I can select multiple edges, and I can apply that fillet command like that, and you'll see that it starts with a radius of 1. We want the radius to be 4 on our Smars, and I'm also going to hold down that command and apply some extra edges. Let's just hold down some extra edges, clicking on that select, oops, not the face, just the edge. If I press in there and do tab, it should update for all the edges, and I'm going to use the option key to help me rotate around this and then shift to move it around, and I'm also going to hold down the option key just so I can select all the edges that I'm after, so that we've now got all these edges here. They should all be 4. So if I click OK, there we go. We've now got some nice round edges. Let's just have a quick look. See if that looks right. Yes, that looks like we've got all the fillets that we want to have. It does mean that these corners are a little bit smaller because that's still quite a tight corner. We want that to be the case inside our Smars robot. We look inside here. It still has quite a tight rectangle on those corner pieces. You can see do come up against the inside edge like that. So I'm going to press 0 just to get back to our nice default shape, and I'm going to click OK. So we've click on back on task. Yep, we've okayed that. So we've completed that fillet command, And what I want to do now is just change those top and bottom faces so that they're a little bit smaller. So what I'm going to do on this one, I'm going to click on the inside face there, and I'm then going to click on that thickness again. Oops, I think I did that wrong. Let me just cancel that out. Click on that. Actually, let's do a pocket on that one, which is this command here. And we can specify what we want that pocket to be. If I do 2mm, let me see if that looks right. If I do a pocket of 1mm, it's just going to take away 1mm from the thickness. I need to do the same with the other side, so let's click OK. And then, actually, let's see if we can do both faces at the same time in the same operation. I'm not sure if it'll let us do that, so let's give that a try. I click on that face as well, click OK. Yeah, I'm not sure it's going to let me do that, so I'm just going to do that same command again. I'm going to do the pocket, and I'm going to change that to be 1mm, just to eat away 1mm of inside surface. So if I toggle the previous one, you can see the difference. Can you see how if I go back to the fillet command and then back to the pocket, you can see that thickness sort of change ever so slightly. And that's to do with when we built our Smiles robot, we've got these different modules that sort of slot in, such as this rangefinder. So this just slots into place, and the slots need to be 2mm, like so, so it slots into place. Like so. It looks a bit wonky there, doesn't it? There we go. Okay, so that's applying the thickness. We've repeated that for the back wall, and we're just going to click yep, done, and return back to that default view like so. Okay, next we want to create some holes for the motors. So the Smiles robot has essentially two motors in it. There's kind of face opposite directions, sort of symmetrically. So there'll be one motor in here and one in here and one in here. And therefore we need a hole on each side, excuse me, so that the motors can sort of poke out their little spindle. Okay, so what I need to do then is, on this face here, we need to create some new geometry where we can draw the side profile, which is this little rhombus shape here, and it gives Smiles that kind of default distinctive look, as well as these. We can do this all in one operation. So I'm just going to select that, and then I'm going to click on Create Sketch, and I'm going to draw a rhombus shape out. So let's just draw that with the line. It doesn't matter how big it is to begin with. We can just need to make sure these lines have the geometry locked to each other. So if I draw a line, I just need to make sure it has that little red X on the cursor when I click on the final one. And now if I right click, that'll deselect the current tool, which was the line tool. So I can now grab these and I can move them around just to make sure that that looks correct, and it does. So I'm going to move this down kind of into place, but not quite fully into place just yet. And what we need to do is lock some of these horizontal lines. So if we use the horizontal on vertical constraint, this is this tool here, we can click on that bottom line and also the top line, and that means that they won't sort of be off to one side, they're going to be completely flat. And the other thing is, we need to make sure that these two are kind of symmetrical. So one of the easy ways to do that is to find the center point of each of these and then connect them with a line, make that line construction geometry, and then make that center line be horizontally constrained. So let's just do that. We'll create a point. Now as I hover towards the center of the line, what you will see, if I zoom in a little bit, when I get towards the center, there'll be a point where you see these little red symmetric constraints being suggested automatically. If I do that over here as well, You might be able to see it on screen, but yeah, if I click there, those two are now at the exact midpoint of the line. So if I now get the line tool, I click on that little point there, drag a line down to the other one. I right click to unselect the tool, click on that again, make it a construction line, and then also make it a constrained horizontally. What we've now done is made these lines completely symmetrical. So if I grab, let's right click on there, if I grab this edge and move it, you can see now that they're symmetrical. So whatever they will be correct. So the next thing to do is to define some dimensions to this. So I'm going to click on the little A button again. I'm going to define the bottom one will be 16 millimeters, the top one will be 28, and then the actual height of this, I'll just check my measurements there, is 10.5. Click OK. Now what I want to do is I want to lock this midpoint here to the midpoint of our base. Now currently, if I try and grab that, this isn't included in our current sketch geometry. We need to bring in what they call external geometry into this sketch. So there's a tool to do that. It's this little blue cube with a little T above it. If I click on that, I can now hover over this edge here. Sort of has like a yellow look to it. If I click on that, you can see that there's now 2 red points and a red line. That means that that's brought that into this sketch. The other thing I can do as well is create a little point on here on the very midpoint, which is just there, and that means now I can then use that coincident constraint to make that point and that point coincident. The sketch has turned green. That means it's now currently completely constrained, locked down. So that's the first job done. We've got that locked. That's the area we're going to sort of punch out in a second. Next, we want to create some holes for our wheel. So I'm just going to create 2 circles randomly over there. Let's create the dimension tool again. Now, I think these are 4.5 millimeters. So the actual width of the spindle on the motor, I believe they're 4 millimeters. So 4.5 is more than enough clearance. So if I do the same with this one, let's just grab that edge, 4.5. And now I want to lock them in place. So they need to be 8. Just find that on there. I think it's 8 millimeters from the top. Yes, there we go. So I need to bring in some more external geometry again. I want to find this left-hand edge, the right-hand edge, and also that bottom edge as well. We want to bring that in. Oops. So it's just complained about that. Let's just do that again. The bottom edge there. There we go. Because I've now brought them in, I can now dimension from those edges to the center point of, like so, the center point of our circle. That needs to be 8. Similar with this one needs to be to the edge point, 8. And then both of them need to be 8 from the very bottom of our design. So that's 8. And that one is also 8. So they've turned green. If I move this slightly over there, you can see now. You can click on these. Just need to deselect the current tool. You can select and move these around just so you can see a bit easier your dimensions if you are not happy with where they're positioned. I don't find the red on the blue very nice, and the green is a little bit too light in my opinion. I quite like the Fusion 360 where it's really clear what the sizes are. We can just move that over there, and that's all we need to do for this particular sketch. I'm going to close that now, and you can see now we've got these white sketches highlighted. You can't see the construction geometry, only the solid lines that you've created. Now interestingly, on Fusion 360 you can individually select different parts of the sketch and do different operations. On FreeCAD each sketch does one operation. So if I want to select this sketch here and I want to actually do a pocket, so I'm going to click on the little pocket command, and I'm going to make this the full length of the model, which is 58. So that's going to punch it all the way through, including the holes for the motors as well. So if I click OK, I can now maneuver around this, and you can see that we've got 4 holes, one for each of the motors or the wheels to live in. Okay. Let's see what else we need to do next. We're whizzing through this, which is good. So the other thing we need to do is we need to create these front and back knockouts, these kind of profiles, and there's 2 different ones we need to create. So one of them goes all the way through, the second one essentially creates a stop place for our Arduino. So what we want to do, we're going to create some slots in a second, but when you see this Arduino stop there, it's stopping because the geometry kind of stops it. There's like a little edge that it doesn't go any further than. So the first thing we need to do is create this area here that's kind of knocked out. So I'm going to do that on the back here. I'm going to click on that, click on Create Sketch, and let me just grab that there. And we do this with a single rectangle. So let's just grab a rectangle, create a little shape, and then we can dimension this out. So click on that little A button, bring this up. That's going to be 42.5 across. And then height wise, this is going to be, so I'm not actually going to define it as a height there. I'm going to define it as a height from the bottom. That means I need to bring in that external geometry using that little Create External Geometry button. Click on the very bottom of our base. Click on that dimension button, and then the bottom edge to the bottom of the base is going to be 14.5 millimeters. Click OK. And what we're going to do is we're going to lock this top edge to the top edge of our geometry there. So we can do that a number of different ways. The easiest way is to project in using that project tool, the top edge. And we can create a midpoint on there as well, just by creating a little point. Click over there, that's now a midpoint. And we can now use the constrain geometry by clicking on that midpoint on the top of our line, and that's now constrained there. Now you might notice as well that it's white. I just click on there, not green, and that means that currently it can kind of move around. So what we probably need to do, let's just undo that last step, and let's create a midpoint up here, and then we can constrain both of them together. So if I now click on the constrain, click on that midpoint, click on that other midpoint, now it's green. Both of those have kind of locked the design in place. So that's what we need to do there. Let's click close, and you can now see the geometry there is ready for us to sort of push that all the way through. So we've got that sketch selected. We're going to use the pocket tool again, and this time we want this to be 70, which is the length of the model, so it goes all the way through. And currently we can't put our Arduino in because both of these have got this little lip. We need to remove one of them. We'll do that very, very shortly. Just making sure we've got that. There we go. So let's do that on the back face again. So I'm going to click OK to complete the operation. Now you can see on the left hand side all the operations kind of stack up top to bottom. I find this a little bit different than Fusion 360. I quite like the timeline based view on Fusion 360. So this view does take a little bit getting used to, because you can see that the actual sketch that we created is now within that pocket operation. I find that kind of moving around with things a bit confusing, but that's just how it works in FreeCAD. We can jump back just by clicking on that little eyeball to see the previous operations that we did. So we can go all the way back to that very original cube, or we can just go back to the latest operation, which is the sort of furthest one down the tree. Right, so what we need to do next then is click on this back edge, click another sketch. Let's just position this a bit better, and we're going to create a rectangle about there, and this rectangle is going to be 52. So let's click on the little dimensioning tool, click on that top edge. It's going to be 52. And this time we are going to define the height of it, so let's just click on the edge, and it's 7.5. Click OK. And let me see what we need to do next. Okay, so I'm going to create a midpoint again using that point, and we'll just drag this to where it's then locks into place as the midpoint. And we can now use the symmetric constraint. Before we do that, we just need to bring in that external geometry of the left hand side and the right hand side. So we've now got this point at the very top left and top right, and we can now use this symmetric constraint. So if I select that left one, the right one, and then the middle one, it's not happy with that. When you see this little red thing appear, that means that it's not happy. There's like an error there. So let's just try that again. Let's try selecting. Let's just right click to unselect. Oops. Just go back into that sketch again. So I'm going to click on the midpoint, and then I'm going to select the 2 points I want it to be symmetric with, and then let's click on that. So it's not happy with that. Why is it not happy with that? It can't find the particular face. So whenever this happens, I always find it's just easier to go kind of back a step. So if I just go back into there, undo, it's going to undo until it's no longer red. And I don't like that little error message being there. Right, let me try that again. So I'm going to click on the midpoint. I'm going to hold down Control, click on the right and left points. And then I'm going to click on the symmetric. I did it last time. Why is that not working? Why is that not working, Kevin? Let me have a look what's going on there. What I might need to do is just make this top point. Let's bring in the top geometry of this line here and here. And let's make this top edge coincident with here. And now I can grab this and it should move kind of left to right. There we go. So now let's try making that point symmetric again. I'm going to select the middle one and click the make symmetrical left and right. Have a quick look at my notes. Project the top and left corners, hold down Control, click the constraint. I did prepare this beforehand. Let me just try that again. This is where I find FreeCAD can be a little bit frustrating compared to other software, but it is free, so we just have to bear with it and do it in the right way. So I'm just going to hover over that and see what it says on there. So I want that point to be symmetrical between that point and that point. So there's another way we can do this. Rather than using the left and right edges, let's bring in the bottom edge here. Let's create a point on this one, just in the middle there. That point isn't currently. It should be on this line here. So let me just do a constraint to geometry on there as well. There we go. And we can now just link a line using the line tool from that midpoint to that edge there. Make it a construction line. Make it a construction line. So I find sometimes as well FreeCAD doesn't update the screen correctly. There is a recalculate model. You can mark things for recalculating. And usually that should update the screen, because what I'm doing here, this operation to toggle the geometry, sometimes it wasn't updating. So I can now lock that in place with that there, and we've got the green. That means everything's good. That's what I needed to do for this particular operation. Okay, let's close that out. We can now see that we've got these extra little edges, and we've got the latest sketch selected in our model tree, and we want to do a pocket, but this time we only want to make it go through 2mm. So if I press 2 in the length there, it's just enough so our Arduino can slide. We're going to create the slots in a second, all the way up to this edge here, kind of replicating, get this in here, this operation where it slides in and then doesn't go any further. It kind of pushes up against those two little lugs. So if I was holding it in, which orientation? That orientation, is that the same? I think it's like that, isn't it? Yeah. So that's kind of the same orientation, and then as it pushes in, it kind of pushes up against these edges here. Okay, I'm going to click OK. That's the first bit done. We need to do the slots. So the slots for the Arduino to slide into. So this is one of the nice parts of this SMARS design. Everything slots and slides into place. There's no screws required. Everything's just kind of friction fit. That's why these dimensions are so important. So this is quite a cool one, because we're going to use the mirror tool. We're going to design on one side and then we're going to mirror across that operation to the other side. So this is why this is quite a cool one to do. We want to create the geometry on the inside wall here. So let's click on that. Let's create sketch, and immediately that sketch is now hidden. We can't actually see. If I rotate this back a second, we're working on this inside surface, but this outer surface is kind of getting in the way. We can't see what's going on. So what we can do is we can use the view and the clipping pane. And if we click on the clipping Y, we can chop half the model so we can now actually see what we're working on, which is this inside face. So if I now click back on number 1, we can now work on the inside face, and that's not getting in the way. So let's create a rectangle. We go to the rectangle tool. We're just going to create this in here first of all, and we want to make sure that this is up against this inside edge, and then this other side is up against this outside edge, and we need to define the height of it. So let's do the dimension tool and make this 2mm, like so. If I grab this, I can also make this above, just so you can see it's 2mm. And we need to bring in the external geometry. Click on that little blue button there to bring in that outside edge and also this inside edge here. And we want to define how high it is from the top edge as well. So make sure we've got that top edge brought in as well. So we now click on that dimensioning tool. We click on that top edge on the bottom edge of our design. And let's just bring this out here. That should be 5.5mm. And we now just need to lock these points. We just need to pick one of the points. Oops. I do this. I pressed a bit too enthusiastically the back button, and it kind of jumps out of that sketch mode. So that's sometimes what you'll see happening there. So I'm going to click on that point there. I'm going to click on the coincident tool. Click on that edge just there. Let's try that again. That edge just there. Make sure we definitely have that brought in. Click on that coincident tool, so we'll select that edge and that point. There we go. And let's do the same on the other side, that point to that edge there. Right, there we go. So it's now happy. Now these are currently construction lines, and that's actually okay. We do want these edges to be non-construction lines, so I'm going to click on that edge there and toggle that one. It's not very easy to see that. Let me just toggle that, so that's now a solid line. And then on the other side, I also want that one to be a solid line. This will make sense in a second. If you can't see, because the actual model's getting in the way, you can go to the model tree. Let's just maneuver some of these down a little bit so we can see a bit better. Just trying to grab hold of that and make that a bit bigger so we can see what's going on. And let's just move that down a bit. So if I go to the model and I just unclick the eyeball, I can now see the lines that I'm working with a bit better. So if I just right click, select that line, and then toggle the construction geometry on that, I want that to be a solid line there. It'll make sense in a second. Why we can now switch that body back on so we can see it. So one of the confusing things when I very first started using FreeCAD was I thought that if you created geometry, so if these weren't construction lines, then it could only go up to this point here. But on FreeCAD, you actually have to specify that this is an enclosed polygon. So we actually have to draw a bit more geometry. So that means on here we have to go to our point tool. We have to we need to bring in, the external geometry of that slant, that diagonal line. We need to create a point, and that point needs to be at the intersection of this diagonal line and the horizontal lines, and similar, we need to do that there as well. If it goes a little bit above or below, that's fine. We can use the coincident constraint to make our little point and that line, for example. Coincident constraint, you can press C to do that as well. And it is misbehaving today. Let's get a bit closer to that point. And if it's not happy with that, we can actually just recreate it. Let's do that again. Let's grab that point, and we want that. But let's just make the point up there, and then make it coincident to that line. It's not happy with that. Let's try it the other way around then. Let's make the oh, so FreeCAD does occasionally crash. Let's just load that back up. And it does say document recovery. Let's indeed do a document recovery on that one. And start recovery. There we go, finish. So let's see where we're up to on that sketch. So we just bring this down into the to the view here. It was just slightly off screen. So yeah, it was complaining about some things. You do get a lot of error messages, I find, in FreeCAD. You've just got to work through each of the issues one at a time. Right, let's just do that operation again. So we're just back to that one where we were selecting that, doing a pocket of 2mm. Click OK, and then we just need to create the geometry on that back wall again. So let's just do that. You save regularly as well. That can also help get into a bit of a habit of just doing Command and S, I think it is, on Mac. So let's just create that geometry again very quickly. Let's do that clipping plane. Click on clipping Y. You can actually close out that dialog box as well if you find that that's kind of in the way. Let's do that rectangle. I'm just going to speed run this bit again, just so that it's a bit easier, a bit faster for me to do this with. So that top line, we want that to be, sorry, we need the height to be 2mm. We want the bottom line, oops, it will always do the same operation. It kind of holds on to it on the cursor. So if you find, let's just go to that clipping plane again. If you find that the current operation is getting in the way, just do a right click and it'll deselect that. So I want that line there to be a construction line, and the top one also to be a construction line. We want that to be, bring in the geometry from the top line, and we want that outside edge and the inside edge, and then we just want to lock them in place. So constrain that to that back wall, constrain that to the outside edge, and we can also just rotate round to see if that looks correct. So that looks like we haven't quite finished that operation on that previous step to me. So I'm going to try something. This can sometimes mess up FreeCAD. If you try and go back and redo an operation, you should be able to do this, but I found in practice this isn't always the case. So let's yeah, it looks like we hadn't finished locking that sketch 3 in place. So yeah, that looks like it's not quite right. So what I just need to do is just do that midpoint operation on that external geometry. Let's just again speed run that. We did this before, so let's just create that. Let's do the line from there to there. Let's right click, select the line, make it construction, make it horizontally constrained, vertically constrained. There we go, close that out. So in theory, that's, yes, it has updated, which is good. Right, let's go back into here and see what this is now complaining about. So let's have a look. I think because we've updated the geometry, is it not? Yeah, it doesn't like the fact that I've changed that right hand side. So the best thing to do, the safest thing to do, is to delete that sketch and just redo it, because if you start editing on geometry that no longer exists, it'll definitely crash. Right, let's just do that again. Oops, creating the wrong things all over the place here. It's that inside. We'll get there with this, we'll get there. Right, view and clipping plane, Y, rectangle, D for dimension, we want this to be 2 millimeters. We're going to bring in the external geometry of that inside and outside edge. There we go, that's better. Constrain that to that edge there, constrain that to that edge there. And then make the right click top, make that construction, and then do D for dimension. We haven't brought in that top edge, let's just bring that top edge geometry in. D for dimension again to the top edge. I think that was 5.5. That looks good. Now what we were trying to do before, let's just make sure we save this time. Right, we've saved that. Let's create a point on this line here, like so, 2 points. Let's bring in the external geometry of that diagonal line, and then we want to constrain those points to that diagonal line. There we go. Now we want to draw a line between those, a solid line, so let's just make sure we get that like so. That's not quite right, you can see there. We just need to constrain that. Click on the constraint tool, that point to that point there. That looks better. Let's just zoom back. Let's just press. Here we go. Now I need to create new lines, even though that we have that construction line, we need to create a new line from that point to that point that we've created, and similarly from that point to that point just there. The green enclosed thing means that that's now the correct geometry that we're after. If we create an operation on that, which will be a pocket, it'll now eat away that material there. We need to do the same on the other side. So I'm going to click on save, and I'm going to create 2 points. That seemed to work well last time. Point and point. Bring in the external geometry of the diagonal line, and then use the constraint tool to make those points constrained to that diagonal line, like so. Let's use the line tool. Let's zoom in a bit. I'm holding down shift as I'm moving around as well, just to make that a bit easier. And now we can create a line from there to there, and a line from there to there. That's it. Let's close that out. Let's save our design again. And we've now got these two. We can also get rid of that clipping plane as well if we want. I found on the Mac as well, you need to sort of double click on the title to bring up these dialog boxes. When for some reason it seems to resize things. And also this clipping plane, the actual close button is off the bottom of the screen. I'm on quite a small Mac, so you can actually grab the top of this title, and if you drag that up there, you can now see the close button to close that out. It's a bit of a tip there. Right, let's go back to our model tree. Let's click on that sketch we've created, and let's do a pocket. And this time the pocket, we want that to be 1.5 millimeters. So you can see there, we've now got, if I just rotate round, that's where we will slide our Arduino in, and then it'll stop as it gets to that inside face there. Now, what I said at the very beginning of this part is we're going to do a mirror operation now. So the mirror operation will repeat all that geometry on operations that we've just done. So we just need to click on the pocket command. We can go to part design and apply a pattern, and mirrored is what we're after. And we want this ZX plane to be our mirror. And I think, do we have to say it's the ZX plane. Yep, you can see that little cutout there tells me that it's done this correctly. If I click OK, we now rotate round our design. You can see now that operation has now been mirrored, both parts of the design. That's really cool. That saves us a bunch of time and also prevents mistakes. Now, one of the reasons that that worked really well is because we created the very beginning, we created that diagonal line with a point at the very center of our, and we centered our model on that XY coordinates on the origin point. Right, just looking to see if there's anything else we need to do there. No, that's good. Making good progress here. So next is the wheel stubs. So these wheel stubs are quite an interesting design on the SMARS robot. So they've got an interesting kind of shape to them. You can see that shape just there. They sort of stick out, and also they have like a cross head, and that enables them to sort of ever so slightly squish together as you put the wheel over it. So the wheels, two of the wheels are powered, and the other two wheels just kind of freely rotate, and they pop on place by sort of using this lug, this sort of wheel stub. So we need to create this and then rotate that geometry round. So what we're going to do is we're going to use the very center of this circle, and we're going to create what they call a datum plane, which is like a sketch geometry plane, and then we're going to draw on that. So let's do all those different steps. So the first thing we need to do, let me just find this, is we need to create a new sketch on this face here. Let's zoom in just on that back motor hole. We need to bring in that external geometry of the actual hole itself. Let's create a point somewhere on there. So the point is just where that circle with a dot is a tangent constraint. That's that one just there. And that means that it's going to stay locked in place somewhere on that circle. So we can see there, wherever I move it, it's going to sort of stay there. Let's now create a line between the center point and that newly constructed thing. Let's make this construction geometry as well. So let's select the line, make it construction, and then let's also lock this in place. Let's make sure it's less than 45 degrees so that when we do the horizontal vertical constraint, it locks it straight vertically down. So that point there is what we're going to use in a second to create this datum plane. So let's close that out. So this datum plane is this button here, this kind of diamond thing. So datum plane, you can see there it's created this yellow shape, but what we want it to be is we want it to be, oops, on that little point that we just created just there. So that little point at the very bottom of that circle. So let's just make, I did find you had to sort of play around with this a little bit to get this to work just right. So let me just find where that is on here. So that's not quite right. We want it to be on that very centered point just there. So I think that actually has a name, that point that we've created. That point has like vertex 55, something like that. But the easiest way is to select it on here. Select the vertex. So it did take me a while to do this one last time as well, as I remember. I'm sure it was on inertia. Let's have a look back on there. Vertex 1. Translate origin. Right, I'm just going to backtrack a second, cancel that, click on that sketch there. I'm just going to hide the body, just make sure I can see that that point does exist. There it is. So that point is called vertex, sketch 5 vertex 1. That's the actual point that we want. Is that somebody did the downwards thumb then? Are they not happy with the progress we're making on here? Right, let's close out that task there. Let's go back to the sketch. Let's go to create datum plane again. Translate origin, that's what we're after. And it's that little point in there. Vertex select. So I don't know why I got it right when I did it, and then now it's not playing ball. Let me just go through those again and quickly find where that is. We could create it as an offset from the edge, but I wanted to do it from that point there, the non-mirrored side. It's like it's only selecting that and not the point that we created in. What we'll do, let's go through. Just back out. Let's go to the model. Let's go to that sketch there. What sketch is that one? That's that one there. Just delete that. I'm just wondering why there's two bodies being present. Maybe that's what's confusing it. Okay. So let's go and create on that surface. Maybe it was when I created the sketch it wasn't quite right. Let's go for that again. Let's bring in that external geometry. Let's create a point. Let's create a line between the points. Let's make the line construction what it is. Let's make sure that point is constrained to the center point. And then let's make that line so that it's vertically constrained. There we go. Let's close out that. Now that we've got that sketch there, we should be able to create that datum plane. Yeah, I'm confused why it's not letting me. Let me go back and rather than being a point, let's make that line so it's not construction. Maybe that's an easier way to do it. Let's go and close that out. There we go. So now we've got a line. Maybe it's easier for us to create that on that line there. And let's just make sure we rotate that. Yeah, that's looking better. So maybe if I did the line horizontally, that would be better. Let's just go back, fix that. So that looks like that's a better option. Let's go back in here. Let's just undo and then make that so that's horizontal. So let's bring that up there. And let's make that now horizontal like that. Now we've got that line, maybe we can create the plane so that it's Oh my goodness, right, why is that? Why is this not working? That's so frustrating. So, is that line we're after? There we go. Bang, we've done it. We've got the edge we're after. You see that's now cutting that circle in half. That's what I was trying to go for. Right, we can now move on. So let's select that plane. Let's now create a new sketch. Perfect. Right. So this shape we're going to create now is quite an unusual shape, and it's the profile that we're going to then rotate round to create the wheel stub. So it's like this. We're going to dimension it all in a second. Okay, those 2 points there are not quite coincidence. Let's just select them both. Use the coincident constraints to lock them in place. There we go. And let's just make these so that they're not construction. And we also want to dimension them and then lock them horizontally and vertically as well. Okay. So that edge there, I'm just going to select that one, make that one horizontal, vertical, constrained. Similar with that top one, let's also make that top one so that it's not construction geometry. There we go. And let's dimension these now. So that edge there needs to be 1 millimeter, as does this top one here. That needs to be 1 millimeter, as does this one here. And then just bring up. So the height of this is 4 millimeters. So from there to the bottom is 4. And the angle that this is at, so if we select that line and then the line there, this needs to be 135, like so, and then the length of it is 10, so from this line here is 10, like so. And what we also want to do is lock this in place on this edge here as well. So let's bring in that external geometry of this edge. And we want to just lock one of the points. Let's do constrain that point to that edge. Now the height of this, we need to find where the middle of that circle is. So if we just ever so slightly rotate round here, we can do that, bring in the external geometry of the circle, and it will create the top point and the bottom point as that kind of crosses through this plane that we're currently editing. So you can now see we've got that point there and that point there. So we can actually create a line between those. So let's click on a line between that point and that point. And we can also then go back into there. Sorry, we can then create a point at the midpoint of that line. It might be easy for us to hide the body again. When the body gets in the way, it's best to just remove that so that we can actually see what we're doing. And in this case, actually, we might want to just see where the midpoint is going to be just there. So we want that point to be there. And what we also want to do is draw a line out from that, kind of pointing out from that. Like so. Doesn't really matter how long that is. It's just going to be a construction geometry line for us so that we can then specify the height of our, I think it is 8 from the very top edge. So let's do D for dimension. The top edge to this bottom line, which is the middle of our circle, is going to be 8 millimeters. It's turned green. That means it's now fully constrained. This will all make sense now as we close this out. Let's go back to our default view. We can actually we can hide that datum plane now. We don't need to see that any further. And you can see now we've got this little shape, and it's the very middle, kind of the center line of our motor hole. So if we now select that sketch and we go to this rotate revolution tool, and we make sure we have this on the correct orientation. And we also want to make sure that so why is that gone so massive? Let's just go back and look at that again. So revolution. That's it. That's what we're after. So it needs to be on the horizontal sketch axis. I'm just going to rotate that round to make sure it is exactly. We go to the number 1 view. You can see that that's now looking correctly centered around that motor hole. Okay, that's good. Now a couple of other things we need to do on this one. If we spin this round and we kind of zoom in a little bit, there is an inside surface there which, if you look there, it kind of is a bit ugly. We want to push that through into our design. So we want to pad that into our design by about 2mm. You can play around with this. If it has like 1mm, for example, you can see it's not quite touching there. So 2mm, make sure it goes inside the thickness of our base without sticking through the other side. Cool. So that's okay. The next thing we want to do is we want to create that kind of cutout shape that we see in our design there. And that will enable these two tabs to ever so slightly squeeze together when we push the wheel over it. So we want to select that face just there. Let's just rotate that around a bit so we can see it a bit easier. And we're going to create a new sketch on that face there. So let's create a rectangle like so. We want that rectangle to not be construction geometry, so let's just select those lines and then toggle them. We want to find the middle of that line there, so create a point in the midpoint, and let's bring in that geometry and that geometry there, so the inside and the outside edges. We can use the tangent constraint to make the top of this line tangent to the top of that line there, and then the tangent to the bottom of that circle. But currently, if I grab the edge of that, we haven't defined what the thickness of this is, so I'll D for dimension, grab that top edge. It's actually 1mm thick, which is quite small. And also, if we grab the outer edge, oops, went a bit too far out there. If I just grab the edge, it's currently not locked in place. So what we want to do is lock it by creating a line between that midpoint that we created on our design. It's easy if you pull it out a bit. Create a line between the center of our circle and the top middle of there. It's good that it's a construction, and then we want to use the horizontal vertical constraints to then lock that in place. It's turned green. That means we've got what we're after there. So now we can then create a new pocket, and we want it to be the depth of that. If you remember from our other sketch, I think it was it 8 millimeters deep. So if we click on the pocket tool, in fact, let's go back, let's click on the sketch, then click on the pocket tool, and we want that to be 8 millimeters. In fact, is it 10 millimeters? Sorry, there we go. You can see that's gone all the way back. That's okay. Click OK, and we've now got the first one of our wheel stubs. Now that was quite a lot of work. It'd be really nice if we could just rotate that round so that it appeared on the other side of our design there. So we can use the pattern tool, the polar tool, to do this. So let me just get to my notes on this one. Let's just see what I need to do first on there. There we go. So what we just need to do is click on the last operation we did, which was that pocket one. That includes all the previous operations before it as well, but we can click on pad revolute as well if we want to select those. Go to part design, apply a pattern, and it's a polar pattern, and it wants to know where are we rotating this from. So let me just move that down a bit there. So what we need to say is we want to rotate this from, the axis is going to be I think it's the Z axis, is it, of our model. So you can see there, it's now rotated that operation. It hasn't done that last one. And I've seen this a few times. What we probably need to do is add a multi-step operation, but to be honest, it's probably easier for us. You can see there you have this create a multi-transform. You can do that. For some reason, these pocket operations don't always work right. But if we just click on OK on this one, let's just close out that. Click OK. It's probably just as well. We can just create a new sketch on this new geometry that we just created there. So let's click on that, create a new sketch, and we can just do that little operation we did before. So create a rectangle, dimension it to be 1 millimeter thick. Let's just double tap the whole thing and make it so it's not construction geometry, like so. Let's zoom right in on it and create that point at the midpoint, which is about there. Let's bring in the outer edge and the inner edge using that project geometry. Create external geometry. Let's create a point. No, we don't need a point. We've already got the center point, so we can just create a line from the middle of our design there to the middle of that circle. Use the horizontal vertical constraint to lock that in place there, and then we can use the tangent. We might need to zoom in a bit here for that top edge to the top of our circle, and then the bottom edge tangent to the bottom of this circle as well. Try that to there. There we go. Close that, and then we can just make sure we've got that selected, do a pocket, and it was 10 millimeters, wasn't it? Deep. Okay. So now I think that's it. I think we have the model. Let's just zoom in to the whole thing. The only thing we haven't got on there is just the inside pieces. So there's just a bunch on there of shapes that we need to create. I think there's 8 rectangles, and then we just pull them up by 10 millimeters. Let's do that. I know we're running over a little bit time-wise, but we can just very quickly do that. So let's just create a bunch of rectangles. Might be easy if we hide our body for now. So let's create some rectangles. And then I think there's another bunch there. You can press space to toggle the visibility once you've actually got it selected, but I don't think that always works if you move on to something else, if you select something else. So let's just grab that. So these all want to be solid, so just double clicking on them on the edge to select the whole thing, and then making so that they're solid lines. And we need to bring in the external geometry for this outer edge, the top inner edge there, because we're going to be connecting these rectangles up. It's just easy if we've got all that geometry already brought in. Okay. And we want to grab this line here, so let's grab we want that little point to be in that very corner there, so let's constrain that to this left edge. Constrain geometry left edge to that point there. That point needs to be up there, and then that edge needs to be over there. And let me just have a quick look. Second to last page. There we go. So I'm going to dimension these. So that is going to be 2 millimeters, and that's 10. These are the bits that hold the battery in place, and I think this one. So the original place I've got these from, if you go to my smarsfan.com, go to the Learn and the Design Studio and click on Chassis. All the actual, I find this is a bit easier to read just because of the way that Fusion 360 designed a lot of the dimension views. There you go. This is what we're currently working on. So it's 3 by 10, not 2 by 10, and then it's 19 from point to point. So we go back on here. That needs to be 3 millimeters, and that needs to be touching that edge there. Come on. And then D for dimension that, and it's the outer edge. So we need to bring in that geometry of the outer edge. And then we can then do D for dimension the outer edge to that outer wall there is 19. And then height wise, let's just flick back to there, let's have a look. So 16 from the top edge to the bottom of our battery holder. So have we got that geometry brought in? Probably not. Let's just grab that top edge. So D for dimension, the top edge to the bottom of our battery holder is 16. And what do we say that needs to be? So this one is going to be 13, this edge here. So that edge to the top needs to be 13. Like so. You could design one set and rotate that round as well. That's also another option. So this one here needs to be, I think this is 2 millimeters, and this tall skinny one is 16.5 from the edge. So from the outer edge, D for dimension. And we've got the external geometry of the outer edge. Let's bring those both in. D for dimension, outer edge to that edge there. 16.5, I think we said. Yep. And then the height of this is going to be 29.5 from the very top edge. So D for dimension, top edge to there. Again, let's just bring in that geometry from the top edge. D for dimension from that top edge to the bottom point there. 29.5. And then we also need to constrain this. Oops. We need to constrain that point to this inner edge there. So we need to make sure we've got that geometry brought in, which I think we have. And then we can use the constraint tool to bring that point to that inner edge there. Okay. And I think there is another battery holder kind of opposite that one. So again, that's going to be 3 millimeters. By 10 millimeters, and that's also going to be 16 millimeters from that top edge, so there to the top edge, 16, and that also needs to be coincident to that line there. Needs to be coincident to that point. Why is it misbehaving? It's because it thinks it's 16 from that center point. That's not what I was after. 16 from there to the top edge. There we go. Keep going too far back on my mouse maneuvers there. Right, let's just make that coincident to that point there, so they're the same. That point needs to be coincident. That point needs to be coincident with up there. Hide the body. See what's going on there. Right, so it seems like that line has got a bit confused there. That point should be coincident with that point there, but it can't. Why can't it? Let's just grab that line and delete it. Let's create a new line from there to there. And make it so it's non-geometry. And then that point needs to be, let's create a line between those, that point there and that point there. Needs to be non-geometry, and then that point needs to be coincident to that point there. There we go. Good grief, that was complicated. And we just need to make sure that that is 10 millimeters, like so. Green, which is good. So let's just view our body, see what that looks like so far. I know we've not done this one down here, but let's just see what this looks like. I'm going to click close on there. Make sure our body is visible. And what we want to do is the kind of final operation is on that sketch. We want to just pad that up by 10 millimeters. So I think it defaults to 10. And click OK. And you can see there now, if I rotate round, ignore that little cube that we've got there. We essentially just need to replicate these on the bottom side, just like on that model there. So it's kind of the diagonally opposite. So you've got that kind of long skinny one, that's where the motors go, and then these little chunky bits just help hold the battery in place in the middle. So it'll look like so when it's finished. So just in the interest of time, I think we've gone on quite long enough there, but that's pretty much our SMARS robot chassis. That's how we build that out. You can see there we've got all the elements that we need. We can now 3D print this. So if we go to File and Export, oops, we need to select the body itself first. File and Export. We can export this as an STL file. So you can see there we can go to a live demo body. We've selected STL mesh, save, and if I go into Prusa Slicer, for example, we can actually try slicing this and seeing if this would actually print. And again, I know I've not done that very last bit. I just want to kind of show you that it does actually work. So if I go to that SMARS body base, that's not the one. That's the one I did earlier. Let's go to SMARS live body demo STL, which we created a couple of minutes ago. You can see there we've now got a body. Again, there's that little piece that we need to finish off that we didn't do. But yeah, we can slice this, and we could print this if we wanted to. This would work. And we just need to make sure we've got some support material on there. Let's just do everywhere. Slice it. So these are designed to print with relatively little support. So there's not much going on there. There is little pieces there, for example, but because they're only 1 millimeter, it's not too bad. I think it does do a bit of, if I do everywhere, let's slice that, it will do a bit of infill on there, just so that it doesn't collapse in on itself. You get some messy bits going on. But yeah, that's how you can create one of those. And yeah, it takes about 2 hours to print out that little chassis, and then you just need to print out all the rest of the pieces. But yeah, that's how we can use FreeCAD to design the SMARS robot chassis. So there we go. Click OK. So again, if you wanted to get the Fusion 360 tutorial, that's available on smarsfan.com. I think I've also got that on kesrobots.com as well, but that was one of the very first video series I did on YouTube, and that was how to design that SMARS chassis. And that one was on Fusion 360. So we've now covered that off, how to do the same thing using some free software. So we don't have to spend £400 a year. We can do this completely free using FreeCAD. Cool. So that's the demo. let's have a quick look what else we need to cover off. If you've not joined our Discord community, head over to kevsrobots.com/discord. You can get a free sign up link there. Just put in your email address, click on the button, and you'll get an email through. It takes about 3 minutes, I think, from Discord, and just check your junk mail if you're waiting on that one. And if you want to follow me on social media, I'm on all the social platforms. So you can see there I'm on Kevin McAleer at threads.net. On TikTok, I'm Kevin McAleer6. On Instagram, I'm at Kevin McAleer. On X, I'm at KevsMac. On Mastodon, at KevsMac at mastodon.social. And on Blue Sky, at kevsmac.bsky.social. If you're on any of those platforms, give me a follow, say hi, and share a picture of a project you're working on. I always like to see what people are working on. And if you want to join the growing army of roboteers, you can do that and support the channel by going to kevsrobots.com/coffee, and you'll find all the instructions there on how to buy a coffee and so on. So I'll give a shout out to all the people who've done exactly that. So if we look on the left hand side here, so Ilana gave me 20 coffees, which was absolutely mind-blowing, and that was to do with SMARS documentation, so on the kevsrobots.com. Somebody bought me a coffee. Michael Carroll bought me a coffee. Simon bought me a coffee. Peter bought me 3 coffees. Martin bought me 2 coffees, and Rory from Jersey IT bought me 3 coffees. Thank you so much for that. Really do appreciate all the coffees that keep me going. Membership wise, we've got Pietro, Warren, Anonymous, Silicon Fiber, Marie TKD, Jeff Johnson, Dean Corty, Marlene, and Tom. Thank you very much for being Buy Me a Coffee members. And then on the YouTube side, we've got Dale from Hybrid Robotics, we've got Brian, Bello, Shashriva, Marie, Pete, Orkrad 39, Warren, PAs, Bert, Michael, Steve, Ford, Stephen, John Paul, Cassie, Johnny, and of course we have Tom. Thank you all for supporting the channel. It means so much to me that you continue to do that, and it has kept me going these couple of months while I've been out of work waiting for my next contract. So really do appreciate you guys supporting the channel like that. And at this point in the video, the spinny logo tells me it's at this point in the video I shall say thank you so much for watching. YouTube has got a video over here that it thinks you'll really like, and definitely click on that one. Let me know what you think about that, and I shall see you all next time. So thanks for watching. Bye for now.